Hello, this is FlippedHarber for Algebra 2. In this video we're going to cover section 6.2, multiplying polynomials. Our objectives for this lesson are to multiply polynomials and use binomial expansion to expand binomial expressions that are raised to positive integer powers. The outline for this video will talk about how to multiply polynomials. We'll talk about what binomial expansion is. We'll take a look at Pascal's triangle and how to create it. And then finally, we'll use binomial expansion with Pascal's triangle. So it's a nifty trick for doing that binomial expansion. Alright, so first of all, let's talk about multiplying polynomials. When you are multiplying polynomials, you need to make sure that each term in the first polynomial gets multiplied with each term in the second polynomial. Now we have a trick for this when we're taking two binomials and multiplying them together. It's the FOIL method. But the FOIL method is just a mnemonic device. It's just a tool to help us make sure we're doing exactly this. It makes sure that we take each term from the first binomial and multiply it by each term in the second binomial. So we just need to make sure that we do this as these polynomials get bigger and bigger. So what I'm talking about doing is taking the x squared from the first polynomial and making sure that I multiply it by both terms in the second binomial. And then take the 2x and do the same thing, and then finally the minus 1 gets multiplied by each term. Make sure that each term in the first polynomial multiplies every term in the second polynomial, and you'll do just fine. So let's take a look at how this will build as we multiply and add terms. So first we multiply the x squared through. We get 3x to the fourth minus 4x squared. Now we take the 2x and multiply it through, and we're adding 6x cubed minus 8x. And then finally multiply that negative 1 through, and we have a minus 3x squared plus 4. Now we're not quite done there. This is a good start. We have each term from the first trinomial, in this case, multiplied by each term in the binomial. We have 6 terms because we took 3 terms and multiplied it by 2 terms. So you should have 6 terms when you finish that first step. But now we need to combine like terms. So we make sure that we put it in standard form. So this 3x to the fourth goes first, then the 6x cubed. Now we combine this minus 4x squared minus 3x squared, and we get a minus 7x squared. Then minus 8x plus 4. Now that it's in standard form from highest power to lowest power and all of the common terms are combined, we're all done. Alright, so let's talk about binomial expansion. Binomial expansion is just literally where we take a binomial, usually our variable x plus or minus a number, and we raise it to some power. In this case we're going to look at a power of 3. Now we have a pretty cool trick for doing this easily, but first I want to look at how we would do this without the trick. This is kind of to make you appreciate the trick. Okay, so I want to cube x minus 4. That means that I need to go x minus 4 times x minus 4 times x minus 4. Okay, the first set, x minus 4 times x minus 4, I'll use the FOIL method to do that. I get x squared minus 8x plus 16. But I still need to multiply by the x minus 4. So I multiply everything through, I combine my like terms, and I have x cubed minus 12x squared plus 48x minus 64. Now, not real difficult work, but look at how many steps this took me to do. Even if I didn't write this step out, which honestly I would probably encourage you to write it out so you don't screw it up, it's still 2-3 big steps. And there's a lot of opportunities for you to screw something up. So let's take a look at a trick to get this done a whole lot neater, a whole lot easier. And it's all built on the idea of Pascal's triangle. Now Pascal's triangle is a tool for us. It's got other purposes, but it's pretty much just used for binomial expansion. This is the only time you're going to see Pascal's triangle. And I don't ever want you to memorize Pascal's triangle. What I want you to do is remember how to make it at will. It always starts with row 0 is just a single old 1 right here. Row 1 is two ones next to each other. Now we're going to use these numbers to create row 2, and then row 3, and then row 4. So let's look at how to create these rows. Every single row begins and ends with a 1. Okay, row 2 begins and ends with a 1. Row 3 begins and ends with a 1. Row 82 starts with 1, ends with 1. The numbers in between are actually the sum of the two numbers above it. So I actually add 1 plus 1 to create this 2. Now let's take a look at row 3. It starts and ends with 1. That never changes. This 3 comes from taking the two numbers above it and adding them. So I take 1 plus 2 to get this 3. Then 2 plus 1 to get this 3. Let's take a look at row 4. Again, beginning and ending with 1, and the 3 numbers in between are the sum of the numbers above. So 1 plus 3 creates this 4, 3 plus 3 creates this 6, 3 plus 1 creates this 4. Here's row 5, and here's row 6. Now, okay, it might be a good idea to copy Pascal's triangle in your notes right now, but I don't want you to memorize rows for Pascal's triangle. I want you to remember how to make Pascal's triangle up to the row that you need to do the binomial expansion. Now, just a little quick tip for you to recognize. Row 2, notice that after the first one, before the second one, the last one right here, there's a 2. It's in row 2, and you see a 2. Row 3 has a 3 here and here. Row 4, row 5, row 6, and this continues on forever. Okay, just something for you to recognize. Now, let's use Pascal's triangle to do this binomial expansion. Now I've got this table here, and I'll tell you what to put in each of these rows for this table. And this is actually going to be a lot easier than actually multiplying out x minus 4. But you have to know what to put in the table. Okay? Because we have a power of 3, that's the row that I need from Pascal's triangle. I need the third row from Pascal's triangle. Don't memorize row 3. Know how to create it. Look back in your notes. Row 3 is 1, 3, 3, 1. That's what goes in this top row, is row 3 from Pascal's triangle. This second row is going to be made from this x. I'll show you how to make it in a second. This third row is going to be made from this minus 4. Now my answer is going to appear in this bottom row. Okay, this is going to be my answer right here. So let's talk about how to fill in the rest of this table. This second row, I start with my x to the third power. Not a coincidence, it's the same power that's on the binomial. So I have an x cubed, and then it goes down from there. X squared, then x, and then the x is gone. This last cell is always empty. This first cell is always empty. It's technically a 1, but let's not get into that. This first cell is empty, and then I have my second term to the first power. So this is negative 4, then negative 4 squared. Notice that it changes sign to a positive, and then negative 4 cubed. Okay, so the top row comes from Pascal's triangle. The second row comes from the first term in the binomial. The third row comes from the second term in the binomial. And now I multiply down the column to create this. So 1 times x cubed is x cubed. Then 3 times x squared times negative 4 gives me this negative 12x squared. Then 48x, and then negative 64. So right here is my answer, if you recognize it. That's the binomial expanded. X cubed minus 12x squared plus 48x minus 64. Now, this may not seem like it saved me a whole lot of time, but this is a whole lot easier as these powers on this binomial get bigger and bigger and bigger. Let's take a look at one that's a little bit bigger. How about x plus 2 to the 5th power. I don't memorize row 5. If you ask me on the street one day, what's row 5? I don't know. But you know what? I know how to make it when I need it. It's 1, 5, 10, 10, 5, 1. So I made up to row 5, and here's row 5 in the table. And now I take my first term to the 5th power, and it goes down from there. This last cell is always empty. This first cell is always empty. And then 2 to the 1st power, 2 squared, 2 cubed, to the 4th power, to the 5th power. And then I multiply, and here are my answers. So when you expand this binomial, it's x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. Way easier than if I had tried to do this out the long way. Okay, that's it. Now for you to try some of these on your own. I'll see you in class, and I will see you online.